Once vertically aligned, we now look for the horizontal alignment. In horizontal alignment, basically what will happen is we'll be taking the motor and moving it towards the camera, away from the camera as far as sideways alignment, which is linear alignment. But for the angular alignment, it would be tilting the motor. Now we check for both. Usually we check for the angular alignment, which is pick a point. So again, we'll use this stripe. Put in a caliper, which I'm reading here, 2.508 inches. Rotate halfway around till I see that same stripe on the other side. And the alignment I see here on this side is 2.506 inches. So it is aligned. Now if it weren't aligned, such as this back number was a much larger number, there would be a case of the motor being tilted this way. And what I have to do is move the motor. You see sideways the angle. Have to move the motor over to fit the angle. I can do this again. Measuring from, taking my same point. Moving the motor tighter in. I'm getting 2.506. Halfway around. And I'm measuring here 2.505. So that is pretty much in alignment there as far as angular. Now for the horizontal, as far as shifting it back and forth, what I prefer to do is take a point, say opposite the set screw, and actually use the caliper depth meter to push down where I have this angle on this side, the depth on this side, and try to measure a mismatch. Which I do here, and I get 0.004 inches. Rotate that around and see if I get the same sort of an angle or a different point. Again, rotate the stick out. I push down. And my misalignment there was, nope, it's still right at 0. Couldn't get my stick into it, so I measure from the other side, pushing off the same. And I get an angle about 0.004. So just about dead on. Once I have that, it's time to do the final torquing down of the motor, which is again to catch this in opposite direction. Catty corner, so to speak. To tighten the torque. Just like you do for torquing. Remember, try to go across crisscross pattern. And once I have that, I'm perfectly well set up. Notice here that when the motor is set up, how easy it is to turn this motor. And you can see through the gear teething, as I turn the Lovejoy, you can see from the markings here, and the marking here, it's very easy to turn this. Now this is heavily geared down. An example here is, notice here, tape here, you can count the revolutions here. One revolution. Two revolutions. Three revolutions. So you notice here the difference between this gear tooth between this spur gear and this spur gear is about a 3-to-1 ratio of distance. If I were to measure that in diameter, is about 1.5 inches to about 4. Not quite a 3-to-1 ratio. If I calculated more correctly, I'd probably find this goes around just as many rotations. Notice the smaller wheel turns many times more than the larger wheel does. That's just an aside in there to keep in mind for speed versus size. In any case, now we're all set and ready to go, and time to continue on with the pony brake and turning on the motor system on.